Hey everyone, welcome to this solution video of assignment number 4. In this particular video, we are going to discuss about the assignment number 4, which was posted in the Telegram group of PyNet Labs. These assignments are part of a $100 giveaway, so if you do want to participate in such giveaways, make sure you join the group from the link given in the description. So let's get started. Let's see what do we have in this particular assignment to solve. So here's our assignment. Assignment says to configure the topology just like we have here in the image and fulfill the requirements which are given in the task. So I can see there are two switches getting connected with each other, having 3 VLANs on each with some end devices being the members of these VLANs. We have VLAN 10, 20, 30, 40, 50 and 60. Then after that we have a task number 1 which says that design the topology as shown above and use the network 200.10.1.0/24 and design subnets to each VLAN using VLSM. So we have to assign the subnets using VLSM and we will be creating some subnets out of this given network. So we have the requirements here for 10, 20, 30, 40, 50, 60 VLAN number, and the requirements are like 30, 10, 12, 100, 25 and 8 respectively. Then after we are done with providing them with the subnets, the next task is to make all the VLANs communicate with each other using SVI and also use EIGRP as a routing protocol. So we'll use SVI to make the communication between these 3 VLANs here and similarly these 3 VLANs on switch number 2. Then in order to make the VLANs connected to switch number 1 communicate with switch number 2, we will need some routing protocol. So we will use EIGRP there. So let's get started without wasting any time and let's begin the calculation of these subnets. So the very first thing to remember while calculating the subnets using VLSM would be that you always have to begin from the requirement which is the greatest. So in this scenario, the VLAN number 40 requires the most users, which is 100 users. So we'll begin the calculation from there only.
If you enjoyed the content of the video, don't forget to like and share the video and subscribe to our channel.
Okay, so the VLAN number 40 requires 128 users. Oh, I guess 100 users. Now 100 users requirement can be fulfilled by a number which is something greater than 100 and also the nearest to the 100 in the powers of 2. So we have to understand all those things. If you want to learn how things are calculated here, you can look for the playlist and you will find the subnetting videos there. Now VLAN 40 requires 100 users. That means I'll be using 2 raised to the power 7, which gives me 128. Now 128 is the number of hosts which I'll be taking here in this particular subnet. If my host bits are 7, then this means automatically my network bits are 32 minus 7, which is 25. So if you want to understand it in a way like this, by default the network and host bits distribution for a /24 subnet is 24 here and 8 here, right? Out of these 8 available bits, we only need 7 bits as we have already calculated. So I'll just subtract the 7 here and the 1 additional bit will be given to the network part and thus makes the network part 25. Now the range will be there from very first IP address, which is 200.10.1.0 and the subnet would be /25. This range will go until 200.10.1.127. The subnet mask which will be used here is going to be 255.255.255.128. This is the calculation for VLAN number 40. Now we will move ahead with the next part, which is basically the calculation for the next greatest users, which are 30 users, and for VLAN number 10. So let's calculate it for VLAN number 10 now. VLAN 10 is there with a requirement of 30 users, which is going to be fulfilled with the help of 2 raised to the power 5, which gives you 32, Now, as I already have shown you how we are calculating this here, if the host bits are 5, then that means the network bits are /27, and the range will be there beginning from 200.10.1.128, because the last IP in the previous range was 127, right? So we will begin it from 128 this time, and this will go until 200.10.1.159. This is going to be the last IP of the range. Now the next thing is to calculate the subnet. So the subnet mask of /27 will be 255.255.255.128 plus 64 plus 32. That gives you 224. This is going to be the subnet mask for the /27. Then after that we need to calculate it for the rest of the VLANs also. Then the next requirement is of VLAN 50 of 25 users. So VLAN 50 requires 25 users, which is again going to be fulfilled with the help of 2 raised to the power 5. This gives you 32. The range is going to be there from 200.10.1.160 to 200.10.1.191, and the subnet mask will again be the same of /27, which is 255.255.255.224. Then let's see what do we have next. We have it for VLAN number 10. We are done. For VLAN number 40 we are done. For VLAN number 50 we are done. The next highest requirement is of VLAN 30, which is of 12 users. I'll just calculate it here on the right side. VLAN number 30 requires 12 users, which is going to be fulfilled with the help of 2 raised to the power 4. This gives you 16. If the host bits are 4, that means the network bits are 28. So the range is going to be there from 200.10.1.192 until 200.10.1.207. If you calculate them, if you count them, these are the 16 IP addresses, and the subnet mask will be /28 subnet, and it is going to be 255.255.255.240. Then the next requirement is of 10 users for VLAN 20, and then it is for 8 users for VLAN 60. So let's calculate it for VLAN 20 first of all. VLAN 20 requires 10 users. Again, 2 raised to the power 4 is equals to 16 will be used. The range is going to be there starting from 200.10.1.208 and will end to 200.10.1.224. Then after that, the subnet mask will be the same, which is 255.255.255.240. Then the last is for the VLAN number 60, where we will have the range from 200.10.1.225 to 200.10.1.239, and the subnet mask is going to be the same as it is above. which is 255.255.255.240. So these are going to be the subnets which we are going to use in the given topology. I have a similar type of topology ready with me, so let's quickly get started. Let's begin the configurational part. So first of all, I'll put the Vlan configurations here on the switches. I'll click on this switch, I'll go to the CLI, we'll say no, enable config T. This is going to be my switch number 1. I'll put VLAN 10, name it as sales, then VLAN 20, name it as marketing, then VLAN 30 and name it as HR, exit. And I'll make the respective members, the respective interfaces participate in their VLANs. So I'll just enable the interface names here. Okay, so I have FA0, 1 and 2 in VLAN number 10, then 3 and 4 in VLAN 20, and similarly 4 and 5. 5 and 6, I guess. This is 4 and this is 5. Sure. So VLAN number, interface number 1 and 2 is there in VLAN number 10, then 3 and 4 is there in VLAN 20, and 5 and 6 is there in VLAN number 30. So I'll go to the CLI, we'll select the range, interface range FA0/1 to 2, and we'll say switch port mode access, switch port access VLAN 10, then exit and select the next range, interface range FA0/3 to 4, switch port mode access. I will enter the range again, switch port mode access, then after that switch port access VLAN 20, exit, interface range FA0/5 to 6, switch port mode access, switch port access VLAN 30, exit. Now we are done with making these interfaces members of their respective VLANs. Now let's do the same on switch number 2 also. I'll go to the CLI, I'll say no, enable config T, host name switch number 2, VLAN number 40, which is going to be there with the name of admin, VLAN number 50 with the name tech, VLAN number 60 with the name sales 2, exit. Then interface range FA0/1 to 2, switch port mode access, switch port access VLAN 40, interface range FA0/3 to 4, switch port mode access, switch port access VLAN number 50. Then similarly for the last range, interface range FA0/5 to 6, switch port mode access, then switch port access VLAN 60, and show VLAN brief. We have the 3 VLANs and the interfaces are there inside the VLANs. Now the next task is to put them into their default networks. Now we have calculated it for VLAN number 10, 20, 30, 40, 50 and 60. So the good thing is that we already have the ranges ready with us here on the screen, and we will be putting the very first IP as the IP of the gateway. So we'll be using the first IP address of the range as the IP address which we are going to assign to the SVI, which is going to act as the gateway, right? So I'll go to the VLAN number 40 and will assign 200.10.1.1 to the SVI for VLAN number 40. So let's begin that now. I'll go to the switch number 2 Here I'll create the virtual interface. First of all, config t, I'll say interface VLAN 40 and assign it IP address 200.10.1.1, 255.255.255.128 and say exit. Then after that we have as VLAN number 10, which is beginning from 200.10.1.128. That means the first IP will be 200.10.1.129 with a subnet 255.255.255.224. Let's put the configurations. I'll go to the packet tracer again, go to the switch number 1, we'll create the SVI interface VLAN 10, IP address 200.10.1.129, 255.255.255.224 and exit. Then we have it for VLAN number 50, which is going to be 200.10.1.161 with a /26, I guess. Yeah. So with a subnet mask of 255.255.255.224. So VLAN number 50. Okay. I'll go to switch number 2 again. I'll create interface VLAN 50, IP address 200.10.1.161, 255.255.255.224 and exit. Then for VLAN 30 we have it as 200.10.1.193 with a subnet mask of 255.255.255.240. I'll go to VLAN number 30 now. Interface VLAN 30, IP address 200.10.193, right? Yeah. So 193, 255.255.255.240 and exit. Then the next we have is for VLAN number 20 here, right? And the very first IP from the range is going to be 200.10.1.209. So let's do it for VLAN number 20 also. Interface VLAN 20, IP address 200.10.1.209 with a subnet mask 255.255.255.240 and then say exit. Last is for VLAN 60. The IP will be 226 with a subnet mask of 255.255.255.240. I'll go to switch number 2 now and we'll say interface VLAN 60, IP address is going to be 1.226, 200.10.1.226, 255.255.240 and exit. We are done with assigning the IP addresses to all the SVIs. Now the time is to put the IP on the PCs. Now it's your choice whether you want to put it statically or whether you want to create the DHCP pools. I think using DHCP pools would be the better option here. So I'll go to this switch, I'll click here and we'll start configuring the DHCP pools for all 3 networks. IP DHCP pool A for the network. The very first network for VLAN number 10 is your 200.10.1.128. So let's create it for that. 200.10.1.128 with a subnet mask of 255.255.255.224 and the gateway address is going to be 200.10.1.129. Then take an exit. Now it's time to create it for VLAN number 20. So IP DHCP pool B for VLAN number 20. VLAN number 20 is there with the range. Here it is. So it is there with a network ID 200.10.1.208 with a subnet mask 255.255.255.240 and the gateway address is going to be 200.10.1.209. 209. Exit. Then IP DHCP pool C for the network of VLAN number 30, which is going to be 200.10.1.192, and the gateway address is going to be 200.10.1.193. Exit. Similarly, we'll create the pools on switch number 2 there. So we are inside switch number 2. We have to create the DHCP pools for VLAN number 40, 50 and 60. So let's begin it from the configuration of VLAN number 40. So we have the VLAN number 40 here. So I'll say IP DHCP pool A for the network 200.10.1.0, 255, 255, 255, 128. The gateway address is going to be 200.10.1.1. Exit. Then IP DHCP pool B for the network of this one, which is VLAN 50, 200.10.1.160, and the gateway address is going to be 200.10.1.161. And the last one, IP DHCP pool C for the network, which is going to be there for VLAN number 60 for the network 200.10.1.225 with the subnet mask, and the gateway address is going to be 200.10.1.226. Exit. Now let's assign the IP address to the PCs and see if they are able to communicate outside their VLANs. I'll go to PC 0, desktop, IP, DHCP, where we are receiving the IP address. Perfect. Perfect. So we have successfully received all the IP requests, and now we have the IP. Let's check if our devices are able to communicate with each other. So if I try to ping from PC 0 to PC 4, first packet failed. It's getting failed again and again because we haven't enabled IP routing here on the switch. So that's an important thing to do when you are using layer 3 switches. I'll say IP routing, and then if I check the routing table, show IP route, do show IP route. We have the routes here. I'll go to this one also and we'll say IP routing. Now if I try to make the communication again, there you go, it's going successful. Similarly, if I try it here from PC 6 to let's say PC 10, okay, I still have to assign IP to them. So I'll go to the PC 6, desktop, IP, DHCP, PC 10, desktop, IP, DHCP. Perfect. So the communication is getting successful. Now we are done with the task number 1 and somewhere with the task number 2 also. But the task 2 also requires the communication between the VLANs of switch number 1 and switch number 2. Now the communication between PC 0 and PC 4, 5, 3 and 2 was successful. But if I try making it communicate with PC 6, it is going to get failed because they don't know about each other's network. So to make that possible, we'll be putting some, we'll be using some network here between FA07 of switch number 1 and switch number 2. So we'll create a network here which is going to be specifically a /30 network. So let's pick it from the same range only. The last range we have is 200.10.1.225 to 200.10.1.239. So what I'm going to use here is I'll be using network 200.10.1.240/30. So I'll be using this network between these two switches. So let's get started. Let's go to the switch, put the IP on the FA07. So I'll go to interface FA0/7, we'll say no switch port, and we'll say IP address 200.10.1.241.255.255.255.252 for a /30 subnet, and say no shutdown, exit. Similarly, I'll go to the switch number 2, interface FA0/7, no switch port, IP address 200.10.1.242, no shutdown, exit. Now we are done putting the IP on FA07 of switch number 1 and switch number 2. Now the next task is to make all of these networks communicate with each other using some routing protocol, for which we are going to use EIGRP. So I'll go to this and we'll first of all have a look into the routing table of switch number 1. If I say do show IP route, I have 4 networks directly connected to me. So let's advertise them into the EIGRP domain. I'll say router EIGRP 10, no auto summary, then network number 1, which is 200.10.1.128, will advertise that with the wildcard mask, because it asks you about the wildcard bits, which is your inverse of the subnet mask. So for /27, which is basically 255.255.255.224, the wildcard mask is going to be 0.0.0.36, not 36, sorry, 31. Then for the network 200.10.1.192, our subnet mask is 255.255.255.240. So the wildcard mask is going to be 0.0.0.15. Then for the network 200.10.1.208, again my wildcard bits are going to be 0.0.0.15. Then finally for the last one, 200.10.1.240, we have a /30 subnet. That means our wildcard bits are going to be 0.0.0.3. That's it. Exit. We are done advertising all the networks on switch number 1. Now it's time to go and configure EIGRP on switch number 2. So here on switch number 2, I'll again look into the routing table, do show IP route. We have 4 networks here also. So router EIGRP 10, no auto summary, and we'll start advertising the networks. So network 200.10.1.0 is there with a /25 subnet. That means 255.255.255.128. So the wildcard mask for this /25 subnet would be 0.0.0.27. Yeah. So it is going to be 0.0.0.127. Then the next network is there with the /27 subnet, 200.10.1.160. The wildcard mask is going to be 0.0.0.31. For 224, we will have 0.0.0.15. And then for the last network, 200.10.1.240, will have 0.0.0.3 and exit. The neighborship is up. If I check the routing table now, show IP route, we have some EIGRP routes there, which are basically for the indirectly connected networks. Now if I try making this communication again, which is between PC0 and PC6, it is getting successful. Similarly, if I try making it communicate, let's say from PC2 to let's say PC10, it is going successful. That's because of EIGRP configuration, which was our task number 2. We are successfully done with the completion of assignment number 4, which required us, which asked us to calculate the subnets using VLSM. Then after that, put the configurations of EIGRP to make them all communicate. I really hope you enjoyed the video and got to learn out of it. Make sure you participate in such assignments or in such giveaways, as it helps you to brush upon your skills. So all the best. Take care. Bye bye. I hope you enjoyed the video.